What's up friends, what's up viewers, it's Prosper here again, and here's another video. In this video, I'm about to show you is how you can solve this particular problem we're about to do. So what can we actually do in this is that it said we should find the point on the curve where y is equal to 2x cubed minus 3x squared minus 12x plus 20 is parallel to x axis. But before we're going to do that, first let's draw a sketch real quick. Now, if we have a sketch, and the sketch is this is our y-axis and this is our x-axis, sorry, and we draw a flow with a turning point, and at this turning point is parallel to x. At this point, turning point is parallel to x. Same thing. So all these turning points are what parallel to x-axis, of which its origin is what equal to 0. So what we're going to do is we're going to differentiate these equation, then we factorize so that we can get a value of x, so that we can actually solve this problem. So let's quickly clean this up, and when we are differentiating this, we'll say what over the y over the x is equal to what? So the power multiply the coefficient is what? 3 times 2x, then the power returns minus 1, minus the power is what? 2 times the coefficient 3, x squared minus 1, minus the coefficient, the power here is what? 1 times 1 times 1. Okay, so times 1, let's say times 1 in brackets, so the power is 1 times, so everything here is minus 12, because if you bring 1 to multiply minus 12, so it will be what? 1 times minus 12, the power returns, which is what? X. Okay, we are not supposed to put that bracket, let's not just put bracket, let's say we now have x minus 1, 1 minus 1, the power is 1, then minus 1. So in indices, s equals to 0 is equal to what? 1. So we now have 1 times minus 12 times 1. So 1 times minus 12 is minus 12. Minus 12 times 1 is still what? Minus 12. So since we know that, we cannot say our answer is just here, minus 12. Okay, so this 20 has no x, so this is gone in calculus, as we know. So we cannot say the y over the x is equal to what? 6x squared, because 3 cube minus 1 is square, minus 6x ordinary minus 12. So what is common here? We can say 6 is common in all, so we divide through by 6. So if we divide through by 6, we'll have 6, we cancel this 6, cancel this 6 1 times, cancel this 12 2 times. So we have the y over the x equals to what? X squared minus x minus 2. So as we said, we can actually factorize this so that we can set this to be an equation equal to what? 0, because you see at the origin of every turning point it is equal to what? 0. So we cannot say x squared minus x minus 2 is equal to what? 0. So factorizing this, so how can we add? What can we add to give us? Know that the coefficient of this x is 1, okay? So what can we add to give us minus 1? And when we multiply the number, it will give us minus 2. So I can say plus 1 minus 2. Plus 1 minus 2 give me minus 1. Plus 1 times minus 2 will give me minus 2, because 1 times 2 is 2. Plus times minus is what? Minus. So this will be my factors. So I'm going to substitute it with this x. So I'm going to substitute this with this. Are you getting it? So I will say x squared. So I will add x because there's x here, because it's x. I will add x to it, add x to it, add x to both sides. Okay? So it will now be plus x, because 1x is x. Then we now have minus 2x minus 2 is equal to what? 0. So let's erase this part. So what's wrong with this? Okay, so we cannot say if we should bracket this, bracket this, bracket this, bracket this, right? So what is common in this space is x. So x is common, open bracket, x plus 1. What is common is minus 2, open bracket, x plus 1. Because minus 2 times x is minus 2x, minus 2 times 1 is minus 2. So because here is having minus, here become what? Plus. So bring the outside together and choose any of the inside. So what we have for the outside is what? X minus 2 is equal to 0. So we choose any one. So we have or x plus 1 is equal to what? 0. So x minus 2 equals to 0, or x plus 1 is equal to 0. So taking this over through the equality sign change to plus, so we have x equals to ordinary 2, and taking plus 1 over the equality sign change to minus, so we have x equals to minus 1. So let's take the equation. So taking the equation, we can now say, so we're going to substitute x4 in this equation so that we can have the x function 1 and the function 2. So we have the f1 function of x. We said what? We have y equals to what? 2. So anywhere we see, so let's take this first one, then we take this one. So you can take them anyways. So you can say, so substitute x for 2. So in this expression, we say y is equal to what? 2s cubed minus 3s squared minus 12x plus 20, right? So we cannot say for this we have, okay, when x is 1, when x is equal to, I want to analyze this so that you will not have issues. So we can say f function of y where x is equal to, we're taking 2. So we can say 2, then x is what? X is what? 2. So we have in bracket 2 close bracket in cube minus x minus 3, sorry. So minus 3 in bracket 2 close bracket square minus 12 in bracket 2 plus 20, right? So we now have this is 2 open bracket 8 minus 3 open bracket 4 minus 24 plus 20. So we have 2 times this is 16 minus 12 minus 24 plus 20. So take these two together, minus 24 plus 20, we have minus 4. 16 minus 12, we have plus 4. So the f function of 2, we can see is equal to what? Is equal to 0. So let's take the function of y where x is equal to minus 1. So we can say, we said what? Y is equal to 2s cubed minus 3s squared minus 12x plus 20. So we cannot say in this case that what? So we cannot say that what? It's equal to what? 2 open bracket minus 1 cube minus 3 minus in bracket minus 1 square minus 12 open bracket minus 1 plus 20. So this is minus 1 in 3 places multiplying themselves is going to give us minus 1. Minus 1 times 2 is minus 2. Minus 1 square is 1. 1 times minus 3 is minus 3. So I have minus 3. Minus times minus is plus. Plus times 12 is plus 12 plus 20. So plus 12 plus 20 plus 32. Then minus 2 minus 3 plus minus 5 plus. Then we have plus 5 minus 32 gives us what? 27. So our f function where is minus 1 is equal to what? 27. So I guess we've gotten that. So we can say we have when it's x2, we can say the coordinate when it's x2 is what? 2, 0, and when it is for the other, when it's for minus 1, when it's for minus 1 is 27. So these are the coordinates of the points, right? So these are the points that showed its parallels. So going back, they say find the points, right? They say find the point on the curve where y is equal to this is parallel to x-axis. So these are the points where x is parallel to x-axis. So what we're going to do right now is we're going to write this in a C programming language, okay? We are going to write this in a C++ programming language. So let's get started. So I've actually written it, okay? So I'm going to write this again. I'm going to write it so that we follow what we are doing. So before we do that, let's quickly run this program. So if it runs very well, we're going to take the equation where y is equal to that equation, and it's going to solve it for us and give us our point. So we said that the point was what? This was the point where y is equal to what? We say where y is equal to 2x cubed minus 3x. So the coefficient of, so this is what we are going to do. We actually took this expression out and simplify it. So we want to write the program. So let me teach you how you are going to write the program that I wrote. So this first term, we're going to take them term 1, term 2, term 3, right? Term 1, term 2, and term 3. So we'll say for term 1, the function of x is what? The coefficient, so this is term 1, 2s cubed. So this is the coefficient of x, and this is the what? The power of x, right? For term 1, same thing apply. This is the coefficient for term 2, this is the coefficient of x, then s squared. So this is what? Power of x, right? So same thing that applies to all the terms, right? So if we run this program, we are going to take the coefficient. He said there is a point. He said enter the coefficient of x1, enter the power of x1, that is term 1, enter the coefficient of x2, power of x2, term 2. Same thing applies. So let's run this program and see what it's going to give to us. So it's enter the coefficient of x1. So it was 2, right? The power was cubed. The coefficient for term 2 is minus 3. The power is squared. The coefficient of the coefficient of the coefficient of s3. Coefficient of s3 is minus 12. So if you remember this, you see that we getting it, and the power was 1. So I said root 1 is 2, root 2 is minus 1. We got that right. Then when you substituting the root of x for 2 in the equation of this, we add 0. Substituting for x for minus 1 in the equation of this, we have 27. Those are the points we got. So we've built a calculator to calculate the point of which we can actually do this, right? So I'm just, instead of writing, for the purpose of longevity of this function, it might take a lot of time, and it might take a lot of time, right? So I'm going to show you how you can actually do this, right? I'm going to show you how you can actually do this. So in doing it in code blocks, we can just create a new project, right? So to create a console project, right? We want to create for C++, and we want to call this points. So click on next right here. We just click on finish. We click on file. We click on recent project. We'll come right here and double tap on it. Ending. Okay, I'm going to reuse this page. I don't know what is happening to this one. So recent project. Okay, let me take this keyboard. Oh, this is what I'll do. Let me just quit this. Let me quit it, right? So let me open it afresh. Oh. Sorry, I don't know why this one is not happening. Did I send that guy? Did I send that guy? Sorry. So let's open up our code block. So you're actually learning how to start up your code blocks, right? You're actually learning how you can do that. So if you like what we're doing, ensure you're subscribed to this channel, okay? Ensure you're subscribed to this channel so that you don't miss out. So open an existing project. Or from here we can also say file, recent projects, points. Okay, so let's build and run this. So once it's run, we know that this okay. So this one is working fine. So we are going to declare our variables first. So the first thing we're going to do is to declare our variables. So we say double double A, comma B, comma C, comma XOR. So when you understand it properly, you understand why I'm using all these variables, right? X1, then we have X2, then X2 power, also have X3 power, X3, comma, X3 power, we have our X x1 times 2 discriminant, right? We have our root 1, we have our root 2, we have our root 1, also have our root 2, right? So we can terminate this now. So from here, you can, let's create a comment so that you can see what you want to do. So in this point, we will take the coefficient of x from the user and the power. Now we can say, let's make this a straight language. Okay, the next thing we can do right here is we want to see out. So we say what? Enter the coefficient of x. Let me use x1. Okay, and then C in. You can see C in. So C in, what do you want to store in that? You want to store x1 and terminate that. So what we're going to do now is we are going to copy this, and we are going to use it instead of rewriting it multiple times. So this one will say x1 power. Okay, we'll say enter the power. Instead of coefficient this time, it says what? Power of x1. So this one will not store this in x1 power, right? So we can paste this coefficient of x2 in this case. We'll call this also 2, right? So let's copy for power now. So x2 power. So we'll call this 2, right? x2 power, yes. Let's be x1 power, x2 power. Okay, so we need the coefficient for x3. So we need the coefficient for x3. So paste that coefficient for s3. Arrow s3. So store this for coefficient of s3. Yes. So we need the power for s3 also. So they can enter it and the calculator will do the rest. So you can say this is for what? X3 power. So we want to store this also in the S3 container. So I guess this is for x1, x1 power, s2, s2 power, s3, s3 power, s3 power. Okay, coefficient power, coefficient power, coefficient power. Okay, since we've done that, the next thing we are going to do now is we are going to do our differential calculation. You know, we then differentiated, right? We differentiated. Let me show you. At this point, we differentiated. Once we enter the coefficient, let me cycling it. When we enter the coefficient, then we enter the power. We enter the coefficient, we enter the power. We enter the coefficient, we enter the power. Then the coefficient and power multiply themselves. Coefficient and power multiply themselves, right? Coefficient and power also multiply themselves. So we got the coefficient and powers, right? So since we got that, for us to get this now, we need to multiply the coefficient and the power. So we're going to do that right away. So we're going to say we want to multiply the coefficient power. So we want to store the answers of the multiple. Let's say we want to store it in ABC because we're going to use ABC for the quadratic equation, right? We're going to use it for the quadratic. So we can say we want to store this in A, and A should be equal to what? X1 times x1 power. So we can say x1 times x1 power. I just want to be very sure of something. X1, I want to double. So we're going to terminate this, okay? So next thing we're going to do is what? P is equal to what? X2 the double times x2 power the double, or the C in. They said the C in, so let's store it. Sorry, let's take the ones for the C in because it's what the enter we want to multiply. So let's take the ones for the C in. If it actually means anything, but if it doesn't, all good because it's still the same thing. X1 power C in. I want the C in variable. I want the C in. I want the C in. So I'm going to do the same thing also for the C. So for C equals to what? X3 C in times x3 C in power. Okay, so I'll terminate this also. So once I've done that, the next thing I want to do is what I want to calculate my discriminant. So because once the coefficient and the power multiply themselves, they are going to become my quadratic factorization. That is ABC. You know, when you want to use almighty formula or quadratic equation, you need to get your A, B, and C right. So let me state my discriminant. So I'm going to say in quotes, I will say the comments. So here I'm calculating my discriminant, right? So those are what I calculate my discriminant. So I'm going to say discriminant double. Get discriminant is equal to what? My discriminant is equal to what? B times B, because we have this B square, right? So B. So those are know what mathematics is. They know this point for discriminant B times B minus 4AC minus 4 times A times C. So this is my discriminant. So once I've got my discriminant, the next thing I want to do is what? I want to calculate the root. So this is my discriminant. I want to calculate my root in this case right now. So I will not say, making a quote at this point, I want to what? calculate my root. So since I want to calculate my root, I will say if in brackets discriminant, right? If discriminant is greater than 0, right? I want to open a function, so open and close curly bracket. So in this function, I want to say what? Root 1, that is root 1 double, should be equal to what? Root 1 should be equal to, in bracket minus b plus the square root okay, we did not declare. Let's be very careful. Let's declare the math function. I use string math. Include I use string math.fish. Yes, include math.fish. So we declare it for mathematics. So it can recognize our square root. Okay. The square root of, in brackets, the discriminant, right? Then we have to close this bracket. Then all should now be what? Divided. All should be divided by that one 2a, right? Open bracket 2 times a. Okay, so from here we terminate this. So that is for root 1. Then for root 2 we just take the same, all of this when it is now what? Minus Ctrl C. So when it is now what? Minus. Okay, now we have minus plus, minus b minus plus, right? So the next one we want to do is what? We want to now calculate. So since we've gotten our roots, okay, we want to calculate x1. So we can say x1. Which one is x1? X1 is the second point. That is the second point. When we say x1, when we substitute the root for x in the y equation, okay? When we substitute the root for x in the y equation, let me show you what I mean by that. And after we got our root in this case is what? Is x equals to 2, x equals to minus 1. Then we substitute it for when x is 2. So this is our x1 and this is our what? X2. So that is what we want to do. So we want to write how we can calculate that, to calculate the substitution of x in that function. The next one we do is what? We say x1 is equal to, in bracket 2 times what? That root 1 times root 1 times root 1, because if we substitute x, the power was cubed, right? The power was cubed. So since the power was cubed, the root is going to multiply itself 3 times. So we now say root 1 times root 1 times root 1 times root 1, that kind of thing. So we say root 1 times root 1 times root 1. Okay, then we have to close the brackets, minus, in brackets 3 times the root 1 in square this time because it was q square 1 power, then the other one was nothing, which was the 20. So we close that, then we have minus in brackets, we have the 12, which is 12 times root 1, then we have plus 20, which was the constant that we had, right? So since we have done this, we can actually calculate for x2. So x2 will just be the same thing, right? But we're going to change the root to root 2. So let's just write it, let's name it. So we can say x2 is equal to, in bracket 2. We've already started root 2, root 2, root 2, minus in bracket 3, root 2, root 2, minus in bracket 12 times root 2 plus 20. Okay, so since we've done that, the next thing that we want to do is what? We want to see out, we want to start expressing what we have calculated. We want the user to start saying what we have done. So the first thing we want to do is what? We want to see out. We want to see out. So what do we want to see out? We want to see out so we want to print out the root, then print out the points. Yes, these are the two things we want to do. Root 1, root 2, want to print it out to the user, then the point 1, point 2 also want to print it out to the user, so that you can have all the 4 points of the curve. Okay, so open and close quotation. So you say root 1, root 1, then x is equal to what? X is equal to, let's say x is equal to the root 1 itself. So for root 1, x is equal to root 1. Yes, because root 1 is this solving, this should be root 2. So root 1, then we need to end line. So end line, we terminate that. So you can also see out so x is also equal to what? X is equal to, so we can say root 2. So once you print that for root 2, then we can end this line. So we also want to see out. In this is see out. So when we substitute root 1, this should be the answer. We'll substitute root 2 for x. Also to substitute root 1 for x, this is the answer. Also substitute root 2 for x, this is the answer I get. So we say see out. So see out, substituting the the root of x. So substituting substituting the root of x for, okay, let's say for 2 in the equation. So what's the equation? We said y. Say y is equal to what? 2x cubed, right? 2x cubed minus 3s squared minus 12x plus 20. Yes, that was the equation. So we've gotten our x1, right? So we can say, are we going to say it's x1, x2, or we say x2, y2? Okay, this one will be what? So this will be x1. Let's see this x1, and this is y1. Let's make it have sense. X1, y1. Yes. Then we can now say this what? X2, y2. So the second point will be x2, y2. So we can now say x2 should be equal to what? x2 should be equal to x1, x2. So it's this point. It's name, say root 1. Root 1 should be equal to x1. Root 2 should be equal to y1. So x1 should be equal to, so x2 should be equal to x1. So this should be x1 so end line, then we can take this whole long line and say it should be what? x2 for here we have the what? y2. Or should we use capital? Okay, let's use capital. So this will be our first statement. So for the next statement, we can say else if discriminant is equal to 0. So you can say open and close curly brackets. So what function do we want in here? So we can say we can see out, but before we start, we can say root 1 should be equal to what? Minus b divided by, in bracket, 2 times a 2 times a we'll say double. So you can see we can double this, right? So if we're doubling this, we can say Cout in double quotation double root you can say root 1 double. So you can see end line, right? And we terminate that. So we can now see for in this case we can also have all of these statements. So in case any statement is printing out, we should also come with this. We can give this to all statements, right? Then for the else case, so we can now say else. You can say else. Then for the else, we can open a function and say in this function root2 is equal to what? B divided by, so you know the other one was minus b, this one will be just b divided by, in bracket 2 times a then we'll say Cout so for the Cout we can say the second root so for the second root we can say this will be for the second root. So now say root 2 end line, then we terminate, then we cannot paste that same thing we have. So anyone is printing, it should also carry the second point, that is the S2 and the Y2 point out. So at this point we can try to test our program. Let's try to test our program before we run it. So let's save this, let's build and run. We enter the coefficient of x1, so it was 2, the power was 2, the other one was 8 minus 3, the power was 12, the coefficient of 3 was minus 12, the power was 1. So 2 minus 1, 0, and 27. So we can furtherly analyze this. We can furtherly analyze this so that we can get the point. Let's say we want to Cout. So at what point do we want to Cout? We want to Cout at this point. So Cout at all points in this case. So Cout, we can say we want to Cout. We can say the point of the curve. So open quotation so that we can see what we wrote. We can say the points on the curve are, so we need to open a bracket again. So are so open a bracket here. So this bracket is opened. We want to print, okay, that means we'll create like this and say root 1. Yes, so we want to bring out root 1. So say root 1 root 1. So root 1, then open and close quotation. In open and close quotation, we put comma. That's what I'm doing. So we can just create this again. So in okay, then we can just say root 2, right? In root 2, we can create this again. So we actually just developing this instance, so we can create a double open and close quotation and put a close bracket in this case now. So we can now copy this up to this point. We can copy up to that point, create this, and paste that one, and create a open, right? So we will now name this one x1, right? We can name this x1, and we name this one x2, and we can terminate this one. So let's save, build and run. So I'm going to copy this function and paste it in all cases. Hope you guys are seeing what I'm doing. So I want it to be like, it should look like a mathematical form. You get. So let's save this, build and run again. So it was 2 cubed minus 3 squared minus 12 1. So as you can see, the points on the curves are 2, minus 1, 0, 27. So we did it. Wow. So this is really awesome. So as you guys have seen, ensure you are subscribed to the channel, because this channel has a lot to give to you. So we have actually created a calculator that can calculate that function for us. So any number we insert, we are very sure is going to prompt us our correct answer. So we are moving to the next class. So thank you guys for watching. See you in the next video. Bye bye for now.